In the previous part, we built the foundation of our employee management system using clean architecture. In this part, let's understand why we designed it this way. We will see how clean architecture helps us build applications that are maintainable, scalable, testable, and extensible through practical examples in our employee management system. Everyone says clean architecture makes our applications maintainable, scalable, testable, and extensible. But what do these terms actually mean? More importantly, how do they help us build better software? We hear these terms in almost every software architecture discussion, but unless we understand them with practical examples, they remain nothing more than technical buzzwords. So, in this video, we are going to do something different. We won't just talk about these concepts. We will first look at how these problems appear in a poorly designed application. Then, we will see how clean architecture solves each of them. And for our every concept, we will first understand the problem, then explore the clean architecture approach, and finally see it in action inside our employee management system. By the end of this video, you will understand not only what maintainability, scalability, testability, and extensibility mean, but also why they matter when building real-world enterprise application. So let's start with a simple question. Why do these concepts matter in the first place? Every software project starts with a simple requirement. We create a few APIs, design a few database tables, and everything looks clean and easy to manage. But that's only the beginning. As the business grows, new requirements keep coming. Today, the business asks us to manage employees. Tomorrow, they ask us for departments, then payroll, leave management, notifications, reports, authentication, and so on. And the application continues to evolve. Building the first version of an application is usually the easy part. The real challenge begins when the application starts changing. Every new business requirement means modifying existing code. And if the application isn't designed properly, even a small change can become difficult. Developer starts modifying these same files, features become tightly coupled, understanding the code takes longer, testing becomes harder, and adding new functionality becomes increasingly risky. So, the real question is, can we design our application in a way that allows it to grow without becoming difficult to understand, modify, test, or extend? That's exactly the problem clean architecture is designed to solve. But instead of answering that with the theory, let's understand it one challenge at a time. Let's start with the first challenge developer face, maintainability. Imagine you are asked to implement a new business requirement. In a well-designed application, you should know exactly where that change belongs. But in many real-world projects, that's not what happens. Controllers become overloaded, business logic gets scattered across multiple files, and a simple change ends up affecting several parts of the application. So, let's first look at the poorly designed implementation and understand why maintaining it becomes difficult. Then we will solve the same problem using clean architecture and compare the difference. Take a look at this controller for a second and check what is it actually doing. It's validating the API request, it's connecting to the database, creating the entity, saving the data, writing logs, and even sending out emails. So definitely it will work. But what's the catch here? Imagine the client comes back tomorrow with a new requirement. Every employee now needs an emergency contact number. So where do we even start making that changes? Do we update the controller, the database, the validation logic, the email service? As an app grows, these pieces get so tangled up that even a tiny tweak becomes a headache. This is exactly what developers mean when they say code is becoming a nightmare to maintain. So let's look at how we can solve the exact same problem using clean architecture. Instead of putting everything inside the controller, let's look at how our solution is organized. Notice that inside the application project, I have organized everything under a feature folder. This is intentional. Instead of organizing the application around technical components like controllers, services, or repositories, I am organizing it around business features because that's how the business thinks. The business talks about employees, departments, payroll, leave management, not controllers or the repositories. Look at this employees folder. Since we are working on employee management, everything related to employees is grouped together inside this feature. This makes the application much easier to navigate. If another developer joins the project and needs to work on employee functionality, they know exactly where to start. Inside the employee feature, we have separated commands and queries following the CQRS pattern. Commands are responsible for operations that modify the data. Queries are responsible for reading data. Since we are creating a new employee, let's look at the create employee command. Notice that everything related to creating an employee is grouped together in one place. Instead of scattering file across different folders, this use case has its own dedicated folder. As an application grows, we will have folders like update employee, delete employee, and get employee by ID. Each business operation remains self-contained, making the solution much easier to understand and maintain. This is our create employee command. Think of it as a business request. It simply contains the information required to create an employee. Notice that there is no business logic here, no database code, no validation. It's just a request object that travels from the API layer to the application layer. Now open the handler. Here is where the real work happens. This is the create employee command handler. When the controller sends the command using mediator, this handler is responsible for processing that request. This is where we implement our business logic. Notice something important here. The handler doesn't communicate directly with SQL Server. Instead, it depends on iEmployee repository interface. In other words, the business logic depends on an abstraction rather than a concrete database implementation. Let me open that interface. This interface defines what the application layer needs. It simply says, I need a way to save an employee. It doesn't care whether data is stored in SQL Server or Postgres or any other database. That responsibility belongs somewhere else. Let me open employee repository. Here is the actual implementation. This class knows about entity framework core, it knows about SQL Server, it knows about DB context, and that's exactly where database specific code should live. The application layer remains completely independent of infrastructure concerns. Now let's open our controller. Compare this controller with what we saw earlier. Earlier, the controller was responsible for validation, business rules, database operations, logging, and sending emails. Now, its responsibility is very simple. It receives the HTTP request and forwards it to the application layer using mediator. That's it. Every responsibility now has a clear defined place. The controller receives the request, the command represents the request, the handler contains the business logic, the repository communicates with the database. The structure makes the application much easier to understand because every developer knows exactly where the particular change belongs, and that's exactly what maintainability means. Maintainability isn't about writing less code, it's about organizing your code and the future changes become simple, predictable, and safe. So that's maintainability. Every responsibility has a clearly defined place. When a new requirement arrives, we know exactly where that change belongs. As a result, our application becomes much easier to understand and maintain. But maintainability isn't the only challenge we face as applications grow. Imagine your application start with just one feature. Then business asks for departments, payroll, leave management, attendance, notifications. The application keep growing. The next question is, can our architecture continue to grow without becoming difficult to manage? That's where the scalability comes in. Let's understand with another practical example. When most developers hear the word scalability, the first thing that comes to mind is handling more users or increasing server capacity. While that's an important aspect of scalability, today we are focusing on something equally important, that is code scalability. As the business grows, new models are introduced, new requirements continue to arrive. Can our application continue to grow without becoming difficult to organize and manage? Let's see what happens in a traditional implementation first. Let's assume this is a traditional application. Initially, the business requirement is very simple. We only need to manage employees. Looking at the project structure, everything seems perfectly organized. We have controllers folder, a service folder, a repositories folder, and our models. At this stage, there is absolutely nothing wrong with this design. But an application rarely stays this small. As the business grows, new requirements continue to arrive. Now, the business asks us to add department management. So we create another controller. Then payroll, another controller. Then leave management, another controller. Notification, reports. Every new business feature introduces another controller. The same thing happens under the services folder. Every feature introduces another service. Over time, this folder keeps getting larger and larger. And same thing happens inside the repositories folder. Every new business requirement adds more classes. The project technically supports more features, but the solution itself becomes increasingly difficult to navigate. Now imagine you are working in a team of 10 developers. One developer is implementing payroll, another developer is working on departments, someone else is modifying the employees management. Everyone keeps working inside the same shared folders. Finding the right files takes longer, understanding the solution becomes harder, and as a project continues to grow, managing the code base becomes increasingly difficult. Notice something important, the application is certainly growing. New business features are being added successfully, but the solution itself isn't growing in an organized way. This is exactly the scalability problem. As the business grows, the code base becomes larger, more difficult to navigate, and more difficult to manage. So, how does clean architecture help us solve this problem? Let's compare it with the way we have organized our employee management system. Now, notice here, instead of grouping everything into large shared folders like controllers, services, and repositories, we have organized the application around business features. Every folder here represents a specific business capability. Here we have employees, departments, payroll, leave management. Each one is responsible for a specific area of business. They are organized independently, making the overall solution much easier to understand. Now imagine the business comes back with another requirement. They ask us to implement asset management. Of course, we still create an asset controller, commands, queries, repository implementations. They are completely expected. Every business capability requires its own implementation. But here is the key difference. While implementing asset management, I don't need to restructure the employee feature. I don't need to reorganize employee files. And unless there is a genuine business relationship, I don't need to modify employee business logic. Instead, I simply introduce another independent feature alongside the existing ones. A few months later, the business asks us to implement attendance management. Once again, we add another feature. Employee management continues working exactly as before. The payroll continues working exactly as before. Existing feature remains stable while the application continues to grow. One interesting thing to notice is this feature based organization. As our application continues to grow, every new business capability gets its own dedicated feature. This keeps the application organized today, and in a future series, we will see how this same feature based organization become a strong foundation when designing microservices. We won't go into those details today, but keep this structure in mind because you will see it again in the upcoming series. Now imagine this application has been running in a production for several years. One team is responsible for employee management, another team owns payroll, another team works on attendance. Since every feature has a clear boundaries, teams can work independently with minimal overlap. Developers spend less time navigating unrelated code and more time delivering business functionality. Now let's compare both the approaches. In the traditional implementation, Every new business requirement made the same shared folders larger. Controllers kept growing, services kept growing, repositories kept growing. Over time, those shared folders became increasingly difficult to navigate. In our clean architecture solution, we are still adding controllers, we are still adding repositories, but every new business capability becomes its own independent feature. Existing features remain organized. New functionality can be introduced with minimal impact on what's already working. And that's exactly what code scalability means. It doesn't mean having fewer classes. It doesn't mean we stop creating new controllers or repositories. It means our application can continue to grow as the business grows, while keeping each business capability organized, independent, and easy to manage. That's what makes an architecture truly scalable. We have now seen how clean architecture helps us build applications that are maintainable and scalable. But there is another important question. How do we verify that our business logic actually works correctly? Do we always need a database to test our application? Or can we test our business logic independently? Let's explore the next characteristic of clean architecture, testability. So far, we have seen how clean architecture helps us organize our code and allows the application to grow in a structured way. But there is another question every developer should ask. How do we know our business logic is actually working correctly? Imagine you have implemented a complex business rule. Before deploying it to production, you would want to verify that it behaves exactly as expected. But should we really need to start the entire application, connect to SQL Server, and execute API request every time we want to test a simple business rule? Probably not. That's where testability becomes extremely important. A well designed application allows us to test our business logic quickly, independently, and with confidence. Let's see how clean architecture makes that possible. Let's first look at how testing becomes difficult in a tightly coupled design. Notice that the business logic and database operations are tightly coupled. This service cannot execute without a real DB context, which means before writing a test, I need SQL Server. I need entity framework core, database configuration, and often even test data. The more dependencies a class has, the harder it becomes to test. Now let's compare with our clean architecture implementation. Now let's see why this business logic is so easy to test in clean architecture solution. Everything starts with our create employee command handler. Notice here this handler doesn't know anything about SQL Server. It doesn't know about entity framework core. It doesn't know about DB context. Instead, it depends only on the iEmployee repository interface. In other words, our business logic depends on an abstraction rather than concrete database implementation. Now look at the handle method. The business logic simply calls the repository through the interface. It doesn't care how the repository saves the employee, whether it's SQL Server, Postgres, or MongoDB, or even an in-memory collection. From the command handler's perspective, all of them behave exactly the same because they implement the same interface. This is the only contract the command handler knows about. It simply says, if someone can add an employee and return it, I can perform my business logic. It never asks whether this implementation uses SQL Server or something else. Here is our real implementation. This class uses Entity Framework Core. It works with DB context. It communicates with SQL Server. This is exactly where database specific code belongs. But notice our command handler never directly depends on this class. Now here is where things become interesting. During unit testing, we simply replace the real repository with another implementation. Notice that this class implements the same interface. The method signature is exactly the same. The only difference is the implementation. Instead of saving data to SQL Server, we simply add the employee to an in-memory list. That's all. No database, no entity framework core, no DB context. Yet from the command handler's perspective, nothing has changed. Because our business logic depends only on the repository interface. We can now inject this fake repository into the command handler. Notice that what we are doing here. Instead of creating the real repository, we are creating the fake implementation. Then we are passing it directly to the command handler. That's the power of dependency injection. Here we are preparing our input data. Now we are executing only the business logic. No controller, no API, no SQL Server, just the command handler. Finally, we come to the assert phase. First, we are verifying that the handler returned a valid employee ID. Since our application uses GUID as a primary keys, we are checking that the returned value is not empty. This confirms that a valid employee was created. Next, we are verifying that exactly one employee exists in our fake repository. This tells us that the business logic successfully added an employee. If no employee was added or more than one employee was added, this assertion would fail immediately. Finally, we are validating the actual data. We are checking the first name, the last name, and the email address. These assertions confirms that the command handler created the employee with exactly the value we expected. In other words, we are verifying the business behavior, not just that the method executed successfully. So, through these assertions, we have verified three important things. First, a valid employee was created. Second, the employee was successfully stored in our fake repository. And finally, the employee contains the correct business data. Now, let's run the test and verify that everything passes successfully. And the test passes successfully. We verified our business logic without SQL Server, without Entity Framework Core, without DB context, without even standing our web API. That's exactly what makes this architecture highly testable. Testability isn't about writing more unit tests. It's about designing your business logic so it can be tested independently of external dependencies like databases, web servers, or third-party services. And that's exactly what clean architecture enables us to do. One important thing to understand is that this unit test is not testing SQL Server or Entity Framework Core. Those components are external dependencies. Verifying that our application correctly communicates with the database is the responsibility of integration tests. Here, our focus is different. We are only verifying that our business logic behaves correctly. By separating unit test from integration test, we get fast, reliable feedback while still having the confidence that our complete application works correctly. Now that we have seen how clean architecture makes our business logic easy to test, let's look at the one final characteristic that makes application easier to evolve over time. Business requirements never stay the same. New features are introduced, existing functionality needs to be enhanced. The question is, can we add new behavior without constantly modifying code that's already working? That's exactly what extensibility is all about. Let's understand it with one final practical example. Let's assume this is our current business requirement. Whenever a new employee is created, we send a welcome email. Everything looks perfectly, but software requirements never stay the same. Now the business says, along with the email, we also want to send an SMS notification. A few weeks later, another requirements arrive. We also need to send Microsoft Teams notification. So here we need to modify the code in this controller. Notice what's happening. Every new notification channel forces us to come back and modify the same controller. Today it's email, tomorrow SMS, next month Teams. Later it could be the WhatsApp or push notifications. This controller keeps changing every time the business introduces a new notification channel. That's exactly what we want to avoid. Let's refactor this using a more extensible design with clean architecture. Now, let's start with the interface here. Notice that our business logic no longer depends on email, SMS, or Microsoft Teams. Instead, it depends on simple abstraction, iNotification service. This interface simply defines the business capability. Send a welcome notification. It doesn't say how that notification should be delivered. That's left to the individual implementations. Here is our first implementation. This class is responsible for sending an email notification. It implements the iNotification service interface and contains only the logic required for email. Now imagine the business asks us to send SMS notification. Notice that we didn't modify the email notification service. We simply introduced another implementation of the same interface. Existing code remains untouched. Later, another requirement arrives. The business now wants Microsoft Teams notifications. Once again, we don't modify the existing email or SMS implementations. We simply introduce another implementation. Every notification mechanism has its own responsibility. And finally, all these implementations are registered with the dependency injection. The dependency injection container now knows about each notification service. Whenever our application needs to send notification, the implementations are available to be used. The important point here isn't the registration itself. It's that adding a new notification mechanism doesn't require us to change our existing business logic. We simply introduce another implementation and registered it. Now let's come back to our command handler here. Notice how clean this class has become. It doesn't know anything about email. It doesn't know anything about SMS. It doesn't know anything about Microsoft Teams. It simply works with a collection of notification services. This loop simply asks every registered notification service to perform its work. If tomorrow the business asks us to introduce WhatsApp notification, we don't need come back here and modify this loop. We simply create another implementation of iNotification service, register it with the dependency injection, and the new behavior automatically becomes part of the application. So compare this with our earlier implementation. Previously, every new notification channel forced us to modify the existing controller. Today, the command handler remains unchanged. New functionality is introduced by adding new implementation rather than modifying existing business logic. That's much safer and more maintainable approach. And that's exactly what extensibility means. Extensibility is the ability to introduce new functionality without repeatedly modifying stable working code. Instead of changing existing business logic every time a requirement evolves, we extend the application by adding new implementations. This reduces the risk of introducing bugs and makes the application much easier to evolve over time. Throughout this video, we have explored four characteristics that make clean architecture so effective. We have seen how it improves maintainability, enables scalability, makes business logic easy to test, and allows the application to grow through the extensibility. So before we wrap up, let's take one final look at the bigger picture and bring all of these concepts together. Now, let's step back and look at the bigger picture. Throughout this video, we didn't just learn four technical terms, we understood why they matter when building real world applications. We started with the maintainability, where we saw how assigning real responsibilities make our code easier to understand and easier to modify. Then we looked at scalability and learned that as the business requirements grow, we should be able to introduce new features without making existing ones increasingly difficult to manage. After that, we explored testability, where our business logics could be verified independently without relying on SQL Server, Entity Framework Core, or the Web API. And finally, we saw extensibility, where new functionality could be introduced by adding new implementations instead of repeatedly modifying stable business logic. Individually, each of these characteristics provides value, but together they form the foundation of a software architecture that remains clean, organized, and easy to evolve, even as the application continues to grow. And that's the goal of the clean architecture. It's not about creating more projects, more folders, or following a particular pattern just because it's popular. It's about building software that's easier to understand, easier to maintain, easier to test, and easier to evolve as the business requirements change. Before we conclude, let's quickly recap the key lessons from this video. Let's quickly recap what we have learned in this video. Maintainability means organizing our code so that it's easier to understand, modify, and maintain over time. Scalability means our applications can continue to grow by adding new business capabilities without making existing features increasingly difficult to manage. Testability means our business logic can be verified independently of the database, web servers, and other external dependencies, giving us fast and reliable feedback. Extensibility means we can introduce new functionality by adding new implementations instead of repeatedly modifying stable working code. Together, these four characteristics make our application more robust, easier to evolve, and better suited for real world enterprise development. If there is one message I would like to take away from this video, it's this: clean architecture isn't about adding complexity, it's about managing complexity as your application grows. In the upcoming videos, we will continue building our employee management system and explore more practical concepts using the same clean architecture foundation. Thank you for watching, and I will see you in the next video.